Ohm's law. The first we'll see the definition. Potential difference between 2 points on a conductor is directly proportional to the current flowing through it, provided the temperature of the conductor remain constant. Now we'll see what does it means. Now let us suppose that this is a conductor and endpoint of this conductor is A, another is B. Now let us suppose the potential of A is greater than B. Then the direction of the current, as I indicated, the direction of the current will from A to B. Now the potential difference between A and B is V. Is V. Then, and the current flowing through the conductor is I. Then V is directly proportional to I, or on the other hand, I is directly proportional to V. Now here you can see, there I am showing that V is directly proportional to I, and R is the proportionality constant, and this R is known as the resistance of the conductor between A to B. Whatever the point in consideration, that between these 2 points is the R is the resistance. Now we'll consider the 3 resistances in series. Now the resistance R1, R2 and R3 are in series, and these 3 resistances are being supplied by a potential V. As a result, a current will flow through all the 3 resistances, and the same current will flow through because they are in series. Now according to the Ohm's law, the potential difference across R1 is V1 is equal to I into R1, because the current flowing through the R1 is I and the resistance is R1. Therefore, according to the Ohm's law, V1 is equal to I into R1. Exactly in the similar way, V2 is equal to I into R2, and V3 is equal to I into R3. And summation of these 3 potential V1, V2 and V3 will be equal to the supplied potential V, that I am showing here, that V is equal to V1 plus V2 plus V3. And if according to the Ohm's law, if we substitute, the V is replaced by I into R, whereas R is the equivalent resistance. That means the resistance between A and B. And then with simplification, we'll find that the equivalent resistance between A and B is equal to R1 plus R2 plus R3. That means that if the resistances are in series, then the equivalent resistance is the summation of these resistances, and that is about when the resistances are in series. Then we can find the equivalent resistance between any 2 points if they are in series. Now we see that when the resistances are in parallel. Now you can see here the 3 resistances R1 and R2 and R3 are in parallel, and these resistances are being supplied with a potential V. Now one thing, when the 3 resistances are parallel, that all R1, R2 and R3 will have the same potential difference across it. Now the current flowing through current I will be divided into I1, I2 and I3 according to the resistances. Now already I told you that across R1 the potential is the same as R2 and R3, and that is V. As we can see in the circuit, that is V, and therefore according to the Ohm's law, according to the Ohm's law, that I1 into R1 is equal to V. Therefore, if we replace that V divided by R1, and similarly here also V divided by R2, and here also V divided by R3, and then I is the equivalent resistance. If we suppose it is R, then B divided by R is while R is the equivalent resistance between A and B. And then we can find, then when resistance is in parallel, then the equivalent resistance we can find. Then equivalent resistance R is equal to 1 by R1, 1 by R2, and 1 by R3. In that way, we can find the equivalent resistances between any 2 points when in these 2 points there are some resistances are in parallel.